Let's look at the notes for quadratic applications, specifically how we can use the quadratic equation to solve problems of vertical motion. So in this video, we're going to learn about how we can use the quadratic equation and the quadratic formula to solve for problems involving vertical motion. And we're going to have two different types of vertical motion problems. The first type is going to be this one, where we have an object that's thrown off of some sort of elevated platform. In this case, we have an object thrown off the roof of a building. So what you can imagine here is we have a building. We might have a person up here who has this ball, and he's throwing the ball up into the air. And then right around this point, gravity is going to start to pull the ball down to the ground. So what we're looking for in these problems on our notes is going to be looking at this value right here on the graph. And that value is the value of time when height equals 0. Because remember, height equals 0 when an object is on the ground. The object would have no height. So let's look and see what that would look like. Now, remember that our quadratic equation, when we're solving for 0, looks like this. 0 equals ax squared plus bx plus c. So what we're going to be given in these vertical motion problems with an object being thrown off of a building or being projected upward, we're going to just slightly modify this to represent vertical motion. So we're going to have, in our examples, if we're solving for when an object hits the ground, we are going to be solving for the value of time when height equals 0. So we're going to have 0 equals negative 16, and in our examples with vertical motion, our value of x is actually going to be our value of time. So we got 0 equals negative 16t squared plus bx. Bx in our vertical motion problems is going to be the product of the initial velocity times, oops, I almost wrote x, times t, plus, and then the value of c is going to be represented by s, which is our platform height, which is a constant. So when we get these problems, we're going to be given this negative 16. And that negative 16 just has to do with the gravitational force when the object starts falling. So that kind of relates to the gravity pulling down the object. And that's something that will be given to you. You won't need to ever figure that out. V times t, v is our initial velocity, or this velocity. Okay, what is the velocity at which the ball is being thrown up into the air? So that value of v is going to be given. And then our value of s is going to be our platform height, which would be the height of the building in this example. And we would put that in, and that would be in terms of feet or whatever measurement the velocity is in. So if the velocity is in feet per second, then our value of s also has to be in feet. So again, when we solve for this equation using the quadratic formula, we are solving for the value of t, okay, just like we're solving for the value of x. So we would go ahead and use the quadratic formula, understanding that t in our vertical motion formula is equal to x in our quadratic formula. So let's write the quadratic formula. We get x is equal to negative b plus or minus the square root of b squared minus 4ac. That needs to be all the way over 2a. So that's our quadratic formula. So what we'll do is we'll input our values from any given word problem and put those in terms of a, b, and c, and then go ahead and put these in the quadratic. So we would have our negative b would actually be negative v plus or minus. This would be, instead of b squared, it would be v squared minus 4 times a, which is always going to be negative 16, times c, which would be our platform height, which would be whatever the height is of the building, divided by 2 times, in this example, would be negative 16. So let's look at the example from the notes on the first page for an object thrown. Fireworks are shot upward with an initial velocity of 125 feet per second from a platform that is 3 feet above the ground. Using the model h equals negative 16 t squared plus vt plus s to find out how long it will take the remains of the fireworks to hit the ground. So a couple of things. We are solving for t, which is this variable here and here, when height is equal to 0, because when an object hits the ground, that means that object has 0 height. So we're solving for 0 when this whole equation is equal to 0. So let's go ahead and write down what the quadratic equation looks like when we're trying to solve. So we have 0 is equal to ax squared plus bx plus c. And then now let's go ahead back to our word problem and write down this equation that we're given. So we are given h equals negative 16 t squared plus vt plus s. So what we can see here, because we've lined these two equations up one on top of the other, our 0 is going to equal our height. Our value of a in the quadratic equation is going to be negative 16. Our value of b from the quadratic is going to be our value of v in this example, which would be initial velocity. And then our value of c for the quadratic is going to relate to s, which is the initial height off the ground, or 3 feet. So let's fill out our table of values over here on the left with our height, our value of h, our value of t, s, and v. So in this example, we are solving for height, and so we're solving what is the t, or what is the value of t when the height is equal to 0. T is what we're solving for, so t is our variable. So t is kind of like our x value. In the equation given, we're given this variable s. S corresponds to the value of c in our quadratic, and I told you that that value would be positive 3. So s equals 3, and again, that's the same thing as c in our quadratic. And finally, we have v, which is velocity. We're talking about initial velocity. That's going to correspond to our b in the quadratic equation, and that's given to us in the problem because we have an initial velocity of 125 feet per second. So v is going to equal 125, and that's going to be our value of b. So now we need to go ahead and write down the quadratic equation, because we are going to use the quadratic equation to solve for t. So if we go ahead and write that, we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Let me expand this top. Okay, now we're just going to go ahead and fill in all the values that we were given. So x is equal to negative b. Again, b is 125, so we're going to write a negative 125 here. X equals negative 125 plus or minus b squared. So we already know that b is 125, so we're going to write 125 to the second power here. So we have b squared is 125 to the second power minus 4 times the product of a and c. So a is negative 16 because a is going to correspond to the negative 16 in our formula for vertical motion. And then finally we need to remember to multiply by c, and c was just 3, or it was the platform height. And then we're going to divide all of that by the product of 2 times a, which is 2 times negative 16. Because again, our value of a is negative 16. Now we're going to go ahead and look underneath the radical sign, and see what we can clean up here so that we can come up with a value for the discriminant. So x equals negative 125 plus or minus. Now we're going to go ahead and do some math inside the radical. 125 to the second power is 15,625. And then when I multiply negative 4 times negative 16 times positive 3, I'm going to have a positive result. So when I multiply negative 4, negative 16, and 3, I get positive 192 all over the product of 2 times negative 16, which is negative 32. Let's go ahead and take this a step further. X is going to equal negative 125 plus or minus. When you add 15,625 plus 192, you should get 15,817 over negative 32. Now we want to look at our discriminant, and we can see that the discriminant is positive. The discriminant is 15,817. Since the discriminant is positive, we know we're going to have two answers. But for a word problem, one of those answers may not make sense. So let's see what that looks like. So we're going to go ahead and continue solving over here. So we get x is equal to negative 125 plus or minus. Okay, the square root of 15,817 was 125.8. You can just do that right on your calculator, divided by negative 32. So you can see that we're going to have two answers because we have this plus or minus, okay? So if in our first example, we're going to use the plus sign. So we're going to take a negative 125 plus 125.8 over negative 32. And that's going to give us a value of negative 0.02. So one of our answers is negative 0.02. And again, we are solving for time, so we know that that cannot be a valid answer. So we're going to finish this one out on the next page. We're back on another page. So again, let's bring up what we were doing on the previous screen. We had x is equal to negative 125 plus or minus the square root of 15,817 over negative 32. X equals negative 125 plus or minus 125.8. 125.8 is just the square root of 15,817, which we found on our calculator, over negative 32. Now on the previous screen I already solved for the negative 125 plus 125.8 over negative 32. When you do that math, you get x is equal to negative 0.02. And we said that this answer, again, x is corresponding to our value of time. So we're saying that t is equal to negative 0.02. So you should know by now that we can't have a negative value of time. So this value, even though it is a solution to the quadratic equation, it's not an answer to this word problem. So let's go back and do it again, but this time we're going to subtract the 125.8. So we're going to get x is equal to negative 125 minus 125.8. So let's see what that would be. 125.8, that's negative 250.8 divided by negative 32. When we do that division, we get an answer of 7.8. So that makes more sense. It's a positive number, 7.8 seconds. So what we're seeing is that once the fireworks are shot upward with an initial velocity of 125 feet per second, the remains of those fireworks are going to be on the ground at 7.8 seconds. Remember, I got two answers with my quadratic because my discriminant was positive. One of those answers didn't make sense because the answer was negative. When I added the negative 125 plus the 125.8, I got a positive denominator over a positive numerator, over a negative denominator, so that gives me a negative answer. When I subtracted negative 125 minus 125.8, I get negative 250.8. So I got a negative over a negative, which gave me a positive 7.8 seconds for my answer. Let's look at another formula for vertical motion, and that is the formula for when an object is dropped. And so that's going to be this formula of negative 16 t to the second plus s, and then my h is equal to 0. So the only thing that's missing from this formula is the product of vt, which was right in the middle of these two terms. But remember, if we're dropping an object, like for example an acorn that's dropping from a tree, or if you dropped a ball from the top of a building, then you don't have any initial velocity. The only movement that that object is going to have is going to be the gravitational force pulling it downward, which results in the just the negative 16 times t squared. So let's go ahead and set up what our values are going to be so we can solve. Again, we're solving this based on the quadratic equation. So you have ax squared plus bx plus c, and all of that is going to equal 0. Now we have our other formula here, which we're given for vertical motion when an object is dropped, of h equals negative 16 t squared plus s. Now this object dropped formula is actually a little bit easier because it doesn't contain that middle term. So we have fewer variables to work with. So our value, if we look at this formula, h equals negative 16 t squared plus s, our value of h, or height, is going to be equal to 0 because we're looking at what is the time it takes for the acorn to hit the ground. And when an acorn hits the ground, its height is equal to 0. So let's keep moving. T is going to equal time, so that's going to be our variable, time in terms of seconds. And then s, that's going to relate to my value of c in the quadratic equation. And we are told that it's falling from a tree just 45 feet from the ground, so our value of s will be 45. So now we're going to look at the quadratic formula and see what that looks like when we don't have a value for b. So if we rewrite this formula, what we really have is h equals negative 16 t to the second plus 0t plus c. Since we don't have an initial velocity, we really have our value of b in the quadratic equation of 0. All right, so let's go ahead and solve this one out. So height is going to equal 0, so we can use the quadratic equation. X equals negative b plus or minus the square root of b to the second minus 4ac, that's all over here, over 2a. So that's going to give us x is equal to negative b. So negative b, remember we don't have a value for b. b is 0, so that's just going to be blank. Negative b is just negative 0, which is nothing. Plus or minus b squared, again 0 to the second power. Minus 4 times a. Remember that our value of a is negative 16, and that has to do with the force of gravity. Negative 16 times c, and remember c is really our value of s, which is our height off the ground, and that we know that's 45 feet. And then we're going to divide all of that by 2a, which is 2 times negative 16. So let's go ahead and simplify that and see what our discriminant is. Well, negative 0 I'm just going to eliminate, plus or minus 0 squared minus 4 minus 16 times 45. I'm going to go ahead and eliminate this part, and I'm going to just come up with the value of my discriminant as being negative 4 times negative 16 plus 45, which is a positive which is going to be a positive product. So we're going to get x is equal to the square root of 2,880 all over negative 32. So you should start, oh, wait a minute, I forgot to put the plus or minus here. That's an important part. So what we have are two answers because our discriminant, again, is positive. It's a positive 2,880. So let's go ahead and see what this looks like. We're going to have two answers. Let me put that in a different color. Okay, so x is going to equal, and if we take the square root of 2,880, let's see what that is. Let's see, square root 2880 is 53. Let's just use 53.7. So we get x is equal to 53.57 over negative 32. So you can see that this answer that we're just looking at here of x equals 53.57 over negative 32, you know that's going to be a negative answer. So at this point, we could almost just cross this out, or we could cross this out and say, hey, this isn't going to be an answer that makes sense, because that answer is negative. So then we know we're going to be subtracting. So x equals negative 53. Whoops, let me erase that and start over again. X equals negative 53.57 over negative 32. So now we have a good situation for a positive answer because we have a negative in the numerator, negative in the denominator. So when I divide those two things out, I'm going to get an answer of x equals, let's see, I'm going to have to put my answer up here. X equals positive 1.68 seconds. So in 1.68 seconds, that acorn will hit the ground.